Hello everyone and welcome to my channel Chemistry by Ms. Nidhi Banga. In today's video, we will be talking about balancing chemical equations. This topic is from the chapter Redox reactions of grade 11. Now there are two methods of balancing chemical equations. First is ion-electron method, also called as half reaction method, which we will be talking about in this video. And then there's this other method called as oxidation number method. We'll be talking about that in my next video. So let's get started. For half reaction method, there are some steps to be followed and you need to memorize those steps. So the first step is, whatever is your chemical equation, you need to divide that into two halves, oxidation half reaction and reduction half reaction. For that, you should be able to recognize the oxidation part and the reduction part. Then, after you have divided the reaction into two halves, for each half reaction, you have to balance every atom other than oxygen and hydrogen. After balancing those atoms, then you get to balancing oxygen atom. That you do by adding water. And hydrogen is balanced by adding H+ ions. Then, after you've done that for both reactions, then balance the charge by adding electrons. After you have balanced charges by adding electrons, then you make sure that the number of electrons for both half reactions are equal. For doing that, you may have to multiply a certain half reaction with an appropriate number. When your number of electrons for both half reactions are equal, then you add those half reactions and cancel out whatever can be cancelled. Okay? Then your reaction is balanced in acidic medium. But if the medium is basic, then what do? In that case, you add hydroxide ions, that is OH- ions, equal to the number of H+ ions, but on both sides. Now let's begin with some examples. So this is our first example. Here, permanganate ion combines with ferrous ion to give you ferric ion and manganese 2+ ion. So let's see what the oxidation and reduction half reactions are. So oxidation number of manganese in permanganate comes out to be +7. How? Let's say you don't know the oxidation number of manganese. Take it as X plus 4 times oxidation number of oxygen, which is -2, equals to the charge on the whole ion, that is -1. So your X comes out to be +7. Okay. Now, +7 is the oxidation number of manganese in permanganate. In case of ferrous, the oxidation number is +2. Ferric, the oxidation number is +3. And manganese here, the oxidation number is +2. Because they are monoatomic ions, and whatever is the charge on monoatomic ions, that becomes their oxidation number. Now we can see that manganese here from in the permanganate ion is getting reduced to Mn2+. So this becomes your reduction half reaction. And ferrous becoming ferric is your oxidation half reaction. Okay, so now let's divide this equation into the two halves. So permanganate ion giving you Mn2+ ion, and then ferrous ion giving you ferric ion. Now, what was the first step? The first step was to balance every other atom other than oxygen and hydrogen. So in this reduction half reaction, permanganate going to manganese 2+, there's one manganese here, one manganese here, no need to balance. Similarly, in ferrous going to ferric, there's one iron on both sides, so no need to balance. Then you balance oxygens by adding water. So there are 4 oxygens here on the left hand side of permagnet, and there's none on the right hand side. So we will add 4 water molecules on the right hand side. Okay. Nothing needs to be done on the oxidation half reaction. Okay, this is your reduction half reaction. Okay, so nothing needs to be done on the oxidation half reaction. Now let's balance hydrogens. In the reduction half reaction, in the reactant side there is no hydrogen, but on the product side there are 8 hydrogens. So what do? We add 8H plus on the reactant side. For that, let me just first move this thing a little here so that there is room for adding 8 H plus ions. Okay, in the oxidation half reaction, nothing needs to be done. Now we balance charge by adding electrons. For that, let's first see what is the charge on the reactant side of reduction half reaction. So here the charge is -1 from the permagnet ion, and then there are 8 H plus ions, so that becomes 8 plus 8. So that gives you a total of +7 charge on the reactant side of reduction half reaction. On the product side, you have manganese 2 plus, so only +2 charge here. Now how would you make these 2 charges equal? By adding electrons. Electrons are negatively charged particles. So if each electron carries -1 charge, these 2 charges can be made equal if you add 5 electrons on this side. If you add 5 negative charge on this side, the left hand side becomes +2. So let's do that. Let's add 5 electrons on this side. Okay. In the oxidation half reaction, on the left hand side, that is the reactant side, we have 2 plus charge, and on the product side we have 3 plus charge. So these charges can be made equal if we added 1 electron on the product side. Now right here you can get a clue that you're doing everything right. In one half reaction, you get to add electrons on the reactant side. In the other half reaction, you must get to add electrons on the product side, so that upon adding the half reactions, you can cancel out the electrons. But before that, we must make sure that the electrons are equal. So here in the reduction half reaction, we have 5 electrons, and on the product side, on the oxidation half reaction, we have only 1 electron. So if we multiply this whole equation by 5, we can make sure that the electrons are 5 in the oxidation half reaction. So this equation now becomes 5 ferrous ions giving you 5 ferric ions and 5 electrons. Now electrons are same in both half reactions. After this, we add the 2 reactions. For doing so, let's write the reactant side of reduction half reaction: permanganate ion plus 8 H plus ion plus 5 electrons, and then we'll write the reactant side of the oxidation half reaction. So that would be plus 5 Fe2 plus ions. This gives you now the product side of reduction half reaction: Mn2 plus 4 water plus 5 ferric ions plus 5 electrons. Now cancel out electrons, and if there's anything other than electrons which can be cancelled, you cancel out that as well. But there's nothing there that can be cancelled. So this becomes our reaction balanced equation in acidic medium. Gives you Mn2 plus 4 water and 5 ferric ions. Now this is balanced in acidic medium. Let's see. So we have 1 manganese here, 1 manganese in the product side, balanced. 4 oxygen in the reactant side, 4 oxygen in the product side, balanced. 8 hydrogen on the reactant side, 8 hydrogens on the product side, again balanced. Then 5 iron here and 5 in the product side, again balanced. But that is the case with acidic medium. What about basic medium? In basic medium, there should be no H plus ions. So what do? We neutralize the H plus ion by adding hydroxide ions. But we need to add that on both sides. So let's do that. You add, okay, this would be acidic medium. In basic medium, I would write the same equation . Okay, and I will add 8 hydroxide ions on both sides. Now 8H plus and 8 hydroxides together, they become 8 water, right? So in place of 8H plus and 8OH, I would just write 8 water. Now let's see what can be cancelled. Again, here we have 8 water and here we have 4 water, so that can be cancelled. So 4 water here becomes nil and here we get 4 water. Okay, now this is the reaction which is balanced in basic medium. Let me just erase this here and write it here. Okay, so moving on, now we will balance a reaction which is disproportionation reaction. In disproportionation reaction, we have an element which undergoes oxidation and reduction simultaneously. Let's see how. So here we have this equation, and in this equation we have phosphorus here in uncombined state P4. So oxidation number here would be 0. Oxidation number, let me just write the oxidation number in a different color. Okay, so oxidation number of phosphorus here is 0. Here in this compound, it's going to be -3. Okay, because oxidation number of hydrogen is +1, that makes phosphorus -3. In this compound, let's find out the oxidation number of phosphorus. We have 2 hydrogens, so 2 times +1. We don't know for phosphorus, so let's keep it X. Then we have 2 oxygens, so 2 times -2, which is the oxidation number of oxygen, equals to -1. So let's solve this. 2 plus X minus 4 equals to -1. X you get as +1. Okay, so oxidation number of phosphorus here is +1. So we can see that phosphorus is going from 0 to -3 here. That makes it reduction. And it's also going from 0 to +1 here. That makes it oxidation. So phosphorus in the reactant is simultaneously getting oxidized and reduced. Okay. What about hydroxide? Now this, we can call this a spectator ion. Why spectator ion? Because it's not taking part in the reaction. It's not part of oxidation half reaction. It's not part of reduction half reaction. You can check out the oxidation numbers of oxygen and hydrogen in hydroxide ion. It remains the same in the products. So it's not taking part in the reaction. It's merely telling you the medium, which is basic. That means we have to balance this reaction in basic medium. Okay, now that we have our oxidation half reaction and reduction half reaction sorted, let's write them. So P4 in the reduction half reaction is getting converted into PH3. In the oxidation half reaction, it's getting converted into H2PO2 negative. Now, the first part of balancing is balance everything other than oxygen and hydrogen. So we have 4 phosphorus here in the reactant part of reduction, but only 1 here in the product. So we make it equal. In the oxidation half reaction, we do the same thing. There are 4 phosphorus in the reactant part of oxidation half reaction, only 1 in the product part. So let's make that equal. Then we balance oxygens by adding water. In the reduction half reaction, there is no oxygen, so no need to balance. In the oxidation half reaction, there are 8 oxygens. So we balance that by adding 8 water here on the reactant side of oxidation half reaction. Then we balance hydrogens. In the reduction half reaction, on the reactant side, we have no hydrogens, but on the product side, we have 12 hydrogens. So we balance that by adding 12 H plus ions here on the reactant side. In oxidation half reaction, we have 16 hydrogens on the reactant side and 8 hydrogens here on the product side. So on the product side, we'll have to add 8 more H plus ions. Okay. Now, we have to balance next the charges. In the reduction half reaction, on the reactant side, we have plus 12 charge because of the 12 H plus ions. On the product side, we have 0 charge. How do we make them equal? By adding 12 electrons on the reactant side. Talking about oxidation half reaction, we have 0 charge here on the reactant side of oxidation half reaction. On product side, we have minus 4 because we have 4 of this anion. Then we had 8H plus, so plus 8 here. So that gives it plus 4 charge. For plus 4 charge, we need to add 4 electrons here. Now that we have added electrons on the opposite sides of the 2 half reactions, we have to make them equal. We do that by multiplying the oxidation half reaction with 3. Okay, we multiply this by the number 3. Now let's write the equations again. P4 here plus 12H plus 12 electrons give you 4PH3. In the oxidation half reaction, we have 3P4 plus 24 water giving you 12 H2PO2 negative, then 24 H plus and 12 electrons. Okay, now we add the 2 reactions. For doing so, I'll take reactant of here P4 plus 12H plus 12 electrons plus reactant of the oxidation half reaction, which has 3P4 here. So I'll just make it 4P4. Okay, then 24 water. Okay, then writing the products of both half reactions. Here we have 4PH3 plus, now product of oxidation half reaction, 12H2PO2 minus plus 24H plus 12 electrons. The electrons need to be cancelled. What else can be cancelled? Hydrogens can be cancelled. 24 here and 12 here. So this becomes 12H plus and this becomes nothing. and electrons also we can remove. Okay, so this simplifies reaction somewhat. Now let's simplify it further. We can take 4 as common. So that makes the reaction P4 plus 6 water, giving you PH3 plus 3H2PO2 minus plus 3H plus. Okay, now we had to balance the reaction in basic medium. So in basic medium there is no H plus ion, so we will add 3 OH minus ions on both sides. Now these 3 H plus and 3 OH minus become 3 water. So let's write that. And now we have 6 water on the reactant sides, so we can cancel it. This becomes 3 water. So here, now this reaction is balanced. Let's see. Phosphorus, 4 on the reactant side and 4 on the product side. How? 1 here and 3 here. Okay. Hydrogens, 6 plus 3, 9 hydrogens, and on the product side we have 3 plus here we have 6, so that becomes 9 as well. Oxygens, we have 3 from water and 3 from hydroxide ion, so that becomes 6 oxygen, and here in this, because 3 gets multiplied with 2, we have 6 oxygens. So this reaction is balanced now. Okay, so this is your balanced disproportionation reaction. Remember that in disproportionation reaction, only one element gets oxidized and reduced simultaneously. Okay, so you have to take the same reactant in reduction half reaction as well and oxidation half reaction as well. And while balancing, you do not have to take into account the spectator ion. Okay. With this, I end my class. Thank you for watching. And if this video helped you, please subscribe, like, and share.